Hey there Python pioneers, and welcome to another video. In this video we're going to be talking about try except statements. They are very useful when you're writing your code, and I want to give you a few examples of why. But first, let's break down some of the errors that you might have seen and how we actually can read that error and see what type of error it is. So for example, to the integer plus to the string, we know that that will not work. And when we run that, we get our error. At the bottom, right before the error description, we get a type error colon. So it's telling us the type of error. And in this case, the type of error is literally type error. And it's just basically telling us, hey, you can't add an integer and a string. Okay, we expected that. Now, if we were to try to run the int function with the word 20, we know that that won't work. The int function requires a string that could be turned into an integer, like the string 20, the actual number 20, right? But let's say we run it with 20, the word, we get a different kind of error. We actually get a value error. So the type of error here is a value error, and it tells us that it's just an invalid literal for the integer, basically saying, hey, I don't know what that is, but it's not a number. Okay, so we've seen a type error, a value error. There's all kinds of errors, but let's just do 100 divided by 0. So in programming, dividing by 0 is undefined. You can't divide by 0. So if you try to divide by 0, you get a 0 division error. And it literally just says division by 0. You can't do that. So different types of errors will throw different types descriptions here before the colon. So now let's look at the try except clause. In some programming languages, it's called try catch. But the idea is we want to write out a try block, and all you type out is the keyword try and a colon. Let me just stop this execution so we get the full screen. So we want to type out a try and a colon. Now if we press enter, we will be inside of the try clause. And basically what you want to do is anytime you have code that could cause an error, you want to put it inside of a try clause. That way, if an error occurs, you can catch it in the exception clause, or the exception statement, or except statement. So 1, 2, 3, 4. It's so large on the screen, it's hard to tell if I'm indented right. So, okay, let's write some code that might cause an error, right? So we're going to create a variable called cost, and it's going to be set to something the user provides with input. And let's prompt the user and say, enter a cost. Okay? And then what we want to do is convert cost to a floating point number, right? Let's say we want to get a floating point number from the user. So we're just going to pass in cost. And actually, before we put this in a try block, I want to show you what will happen before we have the try block. So if we run this code as is, let's add in a print cost or something. Like, we're going to keep going. It says enter a cost. Now if I enter 20, I get that value error, right? And it says, hey, we couldn't convert a string to a float because you literally gave me the word 20. Okay, so if we click stop, let's now wrap this in a try block. Or we call them blocks, but a try statement. Basically, the idea of you calling it a block is you have your clause. So it's kind of, in Python, things are kind of blocked. They're put in little blocks, right? Like inside of each scope, you can also call it a block. Okay. So we're going to try, and if we have an issue, we can say except. So if there's an issue running this code, right now it will just jump down to the except clause and run it. So we're just going to print out the message, there was an error. Okay. So now if we run this code and we enter 20, instead of printing an error, it actually just prints out that message that we wrote out. It just says there was an error. Now, when you look at it this way, this is a great way to look at how try except works, but you want to do a little bit more. Okay. So right now, if there's an error, we have no way of knowing what the error was. We just know there was an error and we caught it in our except statement. That's not particularly useful because if there's any error in this try clause, we're going to catch it no matter what. What you really want to do is be more explicit and look for specific errors, right? So when we ran, when we did a float and we were trying to convert the word 20, right? So I'm just doing it down here in the interactive shell. We got a value error, right? So if we write out, literally, we just take that value that's before the colon and say except value error. So if there's a value error, then do this. So if we run that code, let's see what it does. So if I write out 20, I get there was an error, right? That's great. And it will only run this except clause if there was a value error. So for example, if I do 2 plus 2, right? This wasn't a value error, this was a type error. So if I try to do that, and I say, 20, I still get that type error. It's not caught. So the program still fails because there was a different type of error that I hadn't accounted for with an except clause. So let's show how that's powerful. I can say except value error, and then I can, in my print statement, I can be more descriptive. I can even say something like, you entered an invalid value. Try again. For values, right? And then I could add another except. So you can have multiple, and I can actually say for a type error, I want to do something else. And I could say print, we'll just say there was a type error. And if we run that code and we say 20, so that won't be a value error. So this code, this code runs, no problem. This code runs, no problem. Then we get to line 7 and there's a type error. So it jumps down, it breaks out of this try clause, doesn't run any more code, and it jumps into the except. And it really reads nicely too. So I'm trying to zoom out a little bit so you can see. It reads nicely. So you could even think of it when you read it, try to evaluate 2 plus the string 2, except when there's a type error. When there's a type error, I want you to jump down here and do this. So it's just a nice way to catch those errors. Now, let me show you something else that's pretty cool. This is the preferred way to do it, by the way. You want to be explicit because you notice how in this code I'm able to handle each exception differently. For example, I could actually throw all this. I'll show you the other thing in a second. Let's do while true and just indent all this code. Should have just highlighted along the edge and did it once, but I'm already this far. Okay. So while true, we try to do something, right? And then if we have a value error, we're catching it. So we're not going to break out of the while loop. So let me show you what I mean. So well, actually, let me get rid of this too. So if I run and I say 20, it says you entered an invalid value. Try again. Now look at that. I didn't lose, like my program didn't stop running. Like I was able to have an error because I typed in 20. It was caught by this exception because there was a value error. It printed out, hey, you entered an invalid value, try again. And then it just continues running with the while loop. And I can even add in down here, if I get to this point and I'm able to convert the float, maybe I want to also add in something like, if my cost is greater than or equal to 0, so I can't have a negative cost because that doesn't make sense, then break. So until they enter a cost that's greater than or equal to 0 and can convert to a float, then we're going to keep going. So let me show you. And we don't have a type error right now anyways. So let's just come up here, enter a cost, and let's type the word 20. It says we entered an invalid value, try again, and I can just keep doing that. And as long as I don't type a correct value, it's going to keep asking me. But if I type in a value that can be converted, like 20, and press enter, we break out of the while loop. So this is a really powerful way to do input validation because you really don't know what the user is going to provide when you use input. You're really hoping that they type in what you're saying, but you don't know for sure, you know, maybe they just face rolled on the keyboard. There's no way to know. So what you have to do is wrap it in a try clause or a try statement. And in the try clause, do your whatever you're going to do, you know, get the input from the user, convert it to a float. You're working with that user input, which is kind of unknown. And if they enter something that's incorrect, then, you know, you handle it with an exception. And the way that you can figure this out is when you run your code, try testing out before you put it in a try block like this. Try to just run your code and give bad input and see what kind of errors you get. And if you get an error and it says, you know, value error : then you know, oh, I need to add in an exception for a value error. And I know what causes it because I tested my program to see. Because then you can come down here and handle that exception appropriately. So yeah, that's try and accept. Now there's one more thing I said I was going to show you, which is kind of cool. So before we close out of this one, if we come down here to the interactive shell and I type in help, and like we were looking at value error, right? Let's type in value error with a capital V and a capital E and press enter. Let me scroll this up and let's scroll up to the something. Okay, so it's help on the class value error in the module built-ins. And it says class, which we haven't really talked about yet, but that's okay. It's a value error. And the parameter, which we have learned about, is an exception, right? So the important thing here that we want to look at is that the error is considered an exception. So when we are, you know, when we say except, we're talking about exceptions. And value error is a type of exception. So what we can actually type out here, and notice it's capital E for exception. Something you can type out here that's kind of cool is you can type out exception as E. And this is pretty helpful when you're first like writing your program. At least you don't want to leave it this way, but you know, like I was telling you, when you're testing out your program and you want to see what types of exceptions you run into, what are the errors that happen. You can say accept exception as E. So basically E is now a variable that represents a exception. So any exception that gets passed will be accessible through this variable called E. This is a common practice in Python. So we can print E, and watch what happens. If I type in 20, it actually gives us the error message from the exception. So could not convert string to float 20. Okay, so but we don't have an error. So the reason why you don't want to leave your program this way is because it, like I said, it'll catch all exceptions. And that is not ideal because it's kind of hard in one except block, one except clause to handle all possible scenarios that could happen. So you really want to break out and have multiple except statements for each type of exception you might have. This is just a nice way for debugging. You can at least catch an exception instead of crashing your program and see what the error was. And my program still runs, so I can still type in 20 and then we're done. So, okay. That pretty much covers try and accept. Very useful tools, especially for input validation. When you're trying to use things like float and you're getting input from the user, so you don't really know what they're providing, and there's an infinite amount of numbers, so you can't possibly use an if. And there are always ways you can try to get around using try and accept, so I won't say there's no way. You can get creative and come up with certain ways of doing input validation without using try accept, but this is a powerful tool and you definitely want to keep this one in your toolbox. All right, I appreciate your time. That concludes this video on try accept. I look forward to seeing you in the next video. Thanks.